In this exercise, we have to apply Skolemization, which means to eliminate existential quantifiers. Actually, this formula, what we deal with, is coming from our previous exercise, and it's already in a prefix normal form. You can find two quantifiers, two existential quantifiers, this one and that one. So we want to eliminate them. This is what Skolemization is about. On the top of the screen, you can see the general rule of Skolemization. Basically, if you have an existential quantifier, it disappears, as you can see. And this can only work if you do something with the variable bound by this quantifier. You must substitute this variable with a new term, and this new term is a function call, where the function is a brand new function. We have to introduce it as a brand new function. And what is also important is the parameterization. As you can see that the parameters for this function are coming from the preceding universal quantifiers. Okay, so this is the general rule. Now let's see how to apply it to that formula. So let's deal with the first quantifier, the first existential quantifier, x is x. Since this quantifier is located at the very beginning of the formula, there is no preceding quantifiers, especially no preceding universal quantifiers, which means that the number here, the number k here, which is the number of preceding universal quantifiers, is 0, which means that when I introduce a brand new function for x, let it be f, then I have to use 0 parameters. You see, because I have to use as many parameters as many preceding universal quantifiers I had. Now I have none. This means that this function actually is a constant. You know, constants are functions without parameters. Therefore, if you don't mind, I would use another constant. Let's say c. C is also a brand new constant, so no problem. Okay, so what do I have to do with c? I have to substitute it everywhere in the formula where you can find x. You can find x only at the very end here, and I substitute this new so-called Skolem constant there. And after that, you are free to eliminate the quantifier. Great. Okay, there is one more existential quantifier to go, this guy here. And as you can see, it is preceded by one quantifier, one universal quantifier that binds the variable v. Therefore, we have to introduce a new function, let it be f, with one parameter, with the bound variable v itself. So this is this f of v, what you are supposed to substitute into y everywhere in the formula. You can find y only here. So let me substitute f of v here. That's it. And after you did it, you can replace the existential quantifier like that. So basically, at the end, I get such a formula with only universal quantifiers at the beginning. And actually, this is the goal of Skolemization. As you can see, we want to keep only the universal quantifiers. Okay, so this is the result, but I have something else to tell you, because as you can see, the result highly depends on the order of the quantifiers. Probably you don't remember, but this order of quantifiers was generated by lifting the axis x quantifier first, but it was not a must. So it was based on our previous decision in the previous exercise. We could have lifted that quantifier at the very beginning as well, at the very end as well. So if this happened, then the result would be completely different. And this is what I want to show you now. So let me just alter the formula a bit back to the original version. I only want to change the order of quantifiers. So let me put axis x at the very end of the prefixum. So in this case, of course, the result will be different. First of all, when we eliminate axis y, we can use the same formula with the same parameter here. So f of v, this does not change. But when we are eliminating this axis x quantifier, then we cannot introduce a constant anymore. We must introduce a new function with actual parameters. As you can see, there are two quantifiers preceding the existential quantifier. So we must put both of their variables into the parameter list of G. Therefore, we must substitute x with G of V and Z, and then we can eliminate the axis x quantifier. So in this case, if we start with that order with the quantifiers, this would be the result.